Welcome to this video about proportional thinking. And perhaps you haven't heard the words before, but I'm pretty sure you've used some type of proportional thinking in the past. So just for example, let's pretend you have a part-time job and last week that you made $75. And if this week you worked twice as many hours, I wonder if you could take a guess. If last week you made $75 and this week you're working twice as many hours, how much are you going to make this week? Well, if you can put $150 in there, and you just said, well, it's got to be twice as many, you are already thinking proportionally. So from our graphing summary, here's those different graphs. I think the order might be a little bit different. But that example that we just had about doubling one number and what happens to the other, well, that's proportional thinking. Which one of these five would be an example of what we were just talking about? Take a look at those. Well, really the two variables that we're working with would be, I don't know, wage, how much you made, right? And the number of hours you worked. The one that would probably fit this one the best would be D, where if you said, oh, this would be the number of hours you work, and this would be your wage, right? And if we double one, the other one doubles. So mathematically, we could call this one y is equal to kx, or if we're talking about in terms of proportional, we could say y is proportional to x. Now that's a lot to write every time, that word proportional. So we've got this whole is proportional to. We've got a symbol to mean that phrase so that it's a little bit easier each time. We can just say y is proportional to x. And so what this means is proportional stuff is that if I said, hey, if I were to double x, then what would happen to y? It would also double. So it kind of makes sense if I pick, if this is some amount of x, if I go twice as far, this one lined up with this spot for x, and this one for y. If I double x, then y doubles as well. So that looks kind of neat. Well, let's take a look at some of these other ones here. So if we go and look at A, what's the relationship there? Like as x, if I were to double x in this case, what's going to happen to y? Well, y always stays the same. So this is y. This one's a little bit different than the rest. We're going to call this one no relationship. And y is just equal to some constant. If we want to use the old math term y equals mx plus b, that's fine. So we could just say y is equal to b. We can use b as the constant. So if I multiply x times some number, y always stays the same. All right, let's take a look at b. We'll go through all of these eventually here. So if I can, I'm going to run out of room there, so we'll see what we'll have to do. So if we look at b, as x gets bigger, what's happening to y here? It's getting bigger, and it's getting bigger even more dramatically. Like if here at x at that point lines up with this one for y, and if I double x to say that point, all of a sudden y got really large. So as x gets larger, y gets larger even faster. So you might remember that this is a parabola, and we could also graph this. Instead of graphing y versus x, if we graph y versus x squared, then we would get a straight line from our work before. So I'll just say this is a parabola. Or another way to say this is that, now you'll get used to this, we'll say y is proportional to x squared, because when I graph y versus x squared, I get a straight line. The first one, it's already a straight line, so I just say y is proportional to x, or I should say letter D. On letter B, y is proportional to x squared. So that means that if I multiply x times 2, if I double that, then what's going to happen to y? Well, we already noticed that y gets a lot larger, so in this case y is going to get multiplied times 4. Okay, a little bit different. Which one should we look at next? Let's look at C. In C, as x gets larger, here let's pick this spot and then that spot. So here x corresponds with this kind of value for y. If I make x larger, looks what happened. Y actually gets smaller. So as x gets larger, y gets smaller. This one we called inverse. And if we're to graph not y versus x, but y versus 1 over x, that's when we get a straight line. So we could say that y is proportional to 1 over x. Now what happens? Well, if I double x, or whatever I multiply it by, y is going to get multiplied by the reciprocal. So this would get multiplied times 1 over 2. If I said that this x was going to get multiplied times, say, 1/3, so it's actually getting smaller, multiplying by 1/3, then this y over here would get multiplied by the reciprocal of 1/3, which is 3. So if I made x smaller, y would get bigger. That's how the inverse relationship works. Now this last one over here, the y, it's another parabola, but it's a sideways parabola. Right, this one kind of reminds me of, well, it's part of this parabola you could look at for math. That'd be this y is equal to x squared, right? So y with x squared. This one here looks a little bit different. You might be familiar. You might look at this from math class and say, hey, that reminds me of y is equal to the square root of x. Right, that might look like this. So in case we could actually graph y and the square root of x, and we would get a straight line and get x. So we could say y is proportional to the square root of x. But most often in this class, I like to, instead of having square root, I like to square the y value. If you square the y value, then you get y squared equals x. So this is actually what it looks like on the graphing summary. It's the exact same graph. So instead of doing this stuff over here, we can write here. I'll just erase that. It would be if we were to graph that, it would be y squared and x over here. And so we could say that y squared is proportional to x. So both of these ways are exactly the same, and this is the way it's written on our graphing summary. Well, let's look now. If I were to multiply the x by some value, and I can look at this one, if I multiply this x value, say, times 4, what would happen to the y value? Well, it's inside that square root sign, so maybe you can see the pattern starting to emerge. You would say this would get multiplied times 2. Looking at the way it's written in our graphing summary, it'd probably be easier to say, oh, look at it the other way around. Well, if I were to multiply this times 2, and that gets squared, then my x would get multiplied times 4. Okay, so we can look at this in both ways. I'm going to just end this video now, and you can proceed to the next one.